Good day and welcome back to another wonderful episode of Mr. Math. Today we'll be looking at similarities. Now, we've been doing congruency for about two to 3 days. I did make 3 videos on that, and we are flowing into the last part of the curriculum, which is now similarities. Now, you know that congruency has 4 conditions. But with similarities, you have 2 conditions. So similarities, and with this, the conditions are as follows. So you'll have the AAA condition, which is angle, angle, and angle. So 3 angles that you'll be looking at, and these should be corresponding angles. Okay, and we'll discuss that as well. Or you have the PPP method, and this would be proportion, proportion, and proportion. So this works with the angles over here, and this works with the proportion of the sides of the triangles. I'm going to do 2 or 3 examples for you, just to pace you through it, and just to make sure that you've got as much possible how can I put it this way, resources to assist you with your studies or your homework or so on. So let's jump right into it, and we'll start off with the angle, angle, angle method with regards to similarities. So I'm going to draw 2 shapes, and they will be as follows. So here's the first triangle. Then we'll have the second one. The second one is going to be slightly larger. Remember that your similarities works a lot with enlargement and reduction, because you now need to prove that your shapes are all in the same proportion. Okay, let me just put this down. F is at the top. Then we've got 45 at the bottom here, and we've got 55. Now, something that you must understand with similarities is that it doesn't matter how big your shape becomes or how reduced it becomes, your corresponding angles will always be the same. Okay, so your angles stay the same. It's basically just the proportion of your sides that will change, meaning the actual length of those sides that will be changing with regards to this. Now remember, throughout this whole series we've been working on statement reason. So obviously you'll have statement reason here. So remember, for every statement that you put down, you must be able to have a justified reason. So you must be able to provide a reason with regards to what you are stating here. Okay, then with that, at the end, when you write your conclusion, I'm going to show you how to write your conclusion to ensure that all your corresponding angles or your corresponding sides are written together. Okay, so first of all, we're going to start with the corresponding angles. Over here we've got A, there we've got D. Both of them are on the left, both of them are the same sides. So angle A is equal to angle D, which is equal to 45 degrees. Okay, and your reason there would simply be given, because they gave it to you on the sketch. So given. All of that done, now we move on to our next pair or team of corresponding angles. So we've got B and angle E, and they both equal to 55 degrees. And that's also given because they gave it to you in the sketch. Now you're going to tell me there's no other angles that are equal to one another because there's nothing given. Well, angle F and angle C will be equal to one another, because if I take these 2 angles over here and I calculate the sum of the interior angles of a triangle, I will get my angle C, which is at the top here. The same with this. If I calculate the interior angles of a triangle using these 2 angles, I will get angle F. And remember what I told you, it doesn't matter if the shape is enlarged or reduced, the angles will always stay equal. It is just your sides that will change its proportion. Okay, then, so angle C is equal to angle F. And the reason there is because you have to use the sum of the interior angles of a triangle in order to calculate for those angles. And they will be the same. Okay. With that, you now need to tell me, okay, I've done all of this, I've written all the facts down, I now need to do a conclusion. So therefore, you need to ensure that your angles are written, your corresponding angles are written exactly the same. So if I start with A and I go to B and then C, then I need to start here with D because the corresponding angle for A is D. Then I go to E and then I go to F. Okay, so therefore, angle A, then B, then C. Let me just fill in here. To be triangle, okay, is similar to triangle. The corresponding angle for A is D, for B is E, and for F is C. So, at the end of the day, if you do this, you must be able to do the following. You must be able to link them like this. Look here. See how we link them? And that is how it must be. What comes first must be written first in the corresponding way. Second must go second, and then third must be written third. And then your answer here would simply be that the reason for your statement would be that the corresponding angles are equal in size. Because obviously you used the AAA method in order to get whatever's going on here. Okay. Moving on to our next question with regards to similarities. Our next question will look as follows. So let me just draw the angle or the shape here. There we go. And then we've got a triangle inside of it. There we go. So we'll have A, B, C, which is our main triangle. And then we'll have A, D, and E over here. Then we'll have a 1. I've got a 1 there. There I'll have that. And I'll have a dot, dot, and then again. Okay. So this one is also angled. With regards to this, remember statement reason. Okay. Now, some of you are going to get confused with the fact that one triangle is on top of the other triangle. Okay. And what I'm talking about is that I had in my class that some learners got confused. They're asking, so where's the corresponding angle for A? Now, what you need to understand is that your big triangle is A, B, C. Okay. The corresponding angle for A, for triangle ADE, is also angle A. Okay. You must understand that because the one triangle is drawn on top of the other, both the angles at the top here at the apex, they use exactly the same letter, which is A. Okay. So this is also going to be a AAA method, and after this one we'll carry on with our PPP method. So AAA, remember your first triangle is ABC, that's your big triangle, and then you'll have triangle ADE, which is your smaller triangle in this regard. So first things first, I'm going to use D and B. That's where I'll start. So angle B is equal to angle D1. So angle B is equal to angle D1. And remember, they've indicated to you that these two are the same with those dots. So your answer will, or your reason will be given. Then I'm going to carry on to angle C is equal to angle E1. And that must also be given. They gave it to you here, an indication over there. Then you must understand that angle A is equal to angle A because both the triangles share that angle. And your reason there would obviously be sum of the interior angles of a triangle, like we did with the previous one, as well as you could also say that this angle over here is a common angle. Remember, with congruency we used to common side, and this could be a common angle. Okay, then I've got all of this. I can now make a conclusion. So therefore, triangle, remember that your angles, your corresponding angles, must all align. So if I start at A and I move down and across, then for the smaller triangle I also need to start at A, move down and across. So angle A, B, C is similar to triangle A, D, E. A, D, and E. And when I go draw all my stuff to check what corresponds, all of them should be corresponding like that. Okay, and there you go. Triple A, done and dusted, out of the way. Okay, let's move on to our next question. And this one will work with regards to the triple P method, and this is what it looks like. So our triangles look as follows. We've got one over here. There we go. These ones are a bit weird. There we go. Then the other one, same concept, just a bit smaller. Okay, I tried to make it as small as possible. So the first triangle is P, Q, and R. The second triangle is S, T, and U. Then for this one we've got 5 meters. For this one we've got 2 meters. And then for the one at the bottom is 4 meters. And they tell me the second triangle is 2,5 meters. Then we've got a 1 meter and then a 2 meter. Okay, what you should notice here is the fact that the triangles do not have corresponding angles. Instead, now they've got corresponding sides that you now need to go and look at and sort out. Okay, so statement reason, first thing. Okay, from the statement reason, remember I need 3 facts. There are 3 sides that are corresponding. So I need 3 facts, and for every fact I need a reason. Now what you need to understand is that when you calculate the sides of the triangles, you need to go and see if they are all in the same proportion, which means that you need to go calculate them using ratios. Okay, so you obviously need to divide the corresponding side with the other triangle's corresponding side in order to see if you get the same answer. Now you should get the same answer for all 3, the corresponding sides. Okay, and if you do that, you must understand then that the triangle has either been enlarged or reduced by a scale factor of whatever your ratio gives you. Okay, so how it normally works is we take the first triangle and divide it by the second triangle over there. Okay, so I'm going to start with the corresponding sides, PQ and SU. So PQ over SU. And that would then be 2 meters over 1 meter, and that is equal to 2. So your ratio for these 2 sides is a 2. Okay, then I'm going to carry on with the corresponding sides of QR and UT. So QR, there we go, over UT, and that would obviously be 4 over 2, and that would also give me a 2. Then final sides would then be ST and PR. So PR divided by ST, and that would be 5 divided by 2,5, and that would also give me a 2. So you'll see that your ratio for your corresponding sides are all a 2. So what happened from the big triangle to the smaller triangle is the fact that it was reduced by a scale factor of 2. So they took each of the sides and they divided it by 2 in order to get the smaller image of the original image. Now, all your reasons over here would be given. And the reason why I say all of them are given is the fact that in your sketch, they gave you all the measurements. So that is given to you. Okay? Then, therefore, you need to tell me that triangle, and remember yet again, you need to ensure that your corresponding sides are all in line when you are working with your statement. So we are going to work with the angles, obviously, and then I'll show you how to check if the corresponding sides are mentioned in your conclusion. So first of all, triangle PQR, that is what I'm going to work with. PQR is similar to triangle SU and T, SUT. Okay, now to check if the sides are corresponding sides, you can do the following. So PQ is obviously over here, so PQ, you do this, and SU are corresponding sides. Okay, then you can check QR, QR is over here, and UT, there we go, they are corresponding sides. Lastly, we need to check PR and ST, so PR and ST are corresponding sides. And if you are able to draw smiley faces with regards to your statement, then you know your statement is on point, meaning you have written it correctly. Remember that every single thing needs to be in the corresponding arrangement, if I can put it that way. Then, for your statement, you obviously do need a reason. And the reason here is that the corresponding sides are in proportion. They're in proportion. And there you go, sorted. So with the angles, remember you can draw little brackets. That helps you to make sure that everything's sorted. And with the proportion, when you're calculating sides, you need to be able to draw smiley faces. Then you know your statement is written on point. Okay. I'm going to do one more question with regards to the triple P method, and then we'll call it quits with regards to this video. Okay, one more question. I'm going to do H, question H. So it's a big triangle. Close it off here. There we go. And then we're going to close it off here. Then, with regards to this triangle, so it's going to be A, B, C, and then we've got D over here, and then E at the top. Please note, this is the same as the previous triangle, or not the previous one, the one before the previous one, where the common angle was A. Yeah, the common angle is C. Okay, so then I also put this in, which means that these two are exactly the same in length. We've got 100 centimeters over here. Then they put this in as well to show that these two are also exactly the same length, which means this is 60 centimeters in total. And then obviously they put a 2 and a 1, and also a 2 and a 1. This is a right angle, this is a right angle. And then they also tell us that this is 80 centimeters. Okay, first things first, statement reason. So, which triangle do we work with first? That would always be your question. So, we are going to work with the big triangle, and we're going to take the big triangle and we're going to put it over the smaller triangle, because obviously it was reduced from the big one to the small one. Okay, so first of all, side AC and side BC would be corresponding angles. So AC divided by BC, and that would be 60, because AC is 60. And then you're going to ask me, but what is the length of this side over here? So you basically take the 60 and you divide it by 2. So it will give you 30. And then your ratio would be 2. In your reason, you'll say that it's given because they gave you the measurements. Then, after that, we did side A, C and BC. We now move on to side CE, which is this long side over here, the hypotenuse, and DC. So CE divided by CD, and that would be 100, and again, divided by 2, it will give you 50. So that would be 2. Reason here is also given. Then lastly, AE and BD. So AE divided by BD, which is 80 divided by 40. And that would also be 2, and it's given because they gave you all the measurements in here. Okay. Now I can go make my conclusion. All my ratios are exactly the same, which means that every single side was reduced by 2. Now, therefore, triangle, and remember this is the most important part. If you don't write it correctly, you are sitting with your finger. You don't want it, okay? Because you will lose marks. If you're not able to draw a smiley face, then you know that you've made a mistake. So, when writing this, we're going to say triangle ACE, AC and E is similar to triangle BCD. Triangle BCD. Okay, let's check quickly if we can make smiley faces. So side AC, there we go, and BC, there we go. Then we went to side CE and side CD, which is there. There we go. Then lastly, side AE, which is at the bottom, and side BD, which is at the bottom. There's your smiley faces. And then lastly, your corresponding sides are in proportion. And there you've solved your similarity. Okay guys, this is it for this video. Tomorrow or during the course of the week, I will post another video. It will also be on similarities, but the video that I'll post will focus mainly on the calculation of one of the sides that are missing with regards to triangles of proportion, of similarities in the proportion. So stay tuned. Please ask your friends, invite them to join the channel. I will also do a paper discussion next week. If it's not Monday, I'll do it on Tuesday to ensure that the kids are all sorted with regards to their grade 8 and 9 cycle papers. I will do 2 paper discussions for grade 9 as well as 2 paper discussions for grade 8. It will obviously be live streamed, and it will be between 5 o'clock and 6 o'clock in the afternoons to ensure that everybody is home, sorted, and they can tune in to watch the video. Until next time guys, thank you for all your support. I really do appreciate it, and we'll catch each other on the flip side. Have a good day. Goodbye.